All right, today we are opening one of the biggest, most mind-bending case files in all of science, the invisible universe. We're going to go on a cosmic detective mission to hunt down two mysterious culprits that, believe it or not, shape everything around us, yet they remain completely unseen. So let's start with a number that should honestly just blow your mind. 95%. Yeah, that's how much of our entire universe is made of stuff we can't see, can't touch, and you know what? We really can't explain. Everything we think we know, it's just the tiniest tip of a massive cosmic iceberg. And that 95%, well, it breaks down into two majorly mysterious components. About 68% is something we call dark energy, and another 27% is dark matter. And that little 5% sliver left over, that's everything else. Every star, every galaxy, every single planet, and every atom that makes you, you. It's kind of wild when you think about it. So this is it. This is the central mystery we're digging into today. Where is this missing 95%? What is it? And maybe most importantly, what does it mean for the ultimate fate of our universe? It means the reality we see and interact with every day is just a tiny, tiny fraction of what's actually out there. So with that humbling thought in our minds, let's go ahead and meet our first main suspect. First up in our cosmic lineup is suspect number 1, dark matter. Probably the easiest way to think about it is as the universe's invisible glue. Or maybe it's hidden scaffolding. Okay, so here's the most crucial point. Dark matter doesn't give off light, it doesn't reflect light, it doesn't even block light. That's why we literally can't see it. But, and this is a huge but, it does have mass. A lot of it. And that means it has gravity. It's this silent, heavy presence that's holding the entire cosmos together. Which, of course, brings up the most obvious question, right? If this stuff is totally invisible, how on earth are we so sure it even exists? Well, like any good detective, astronomers have been following the gravitational breadcrumbs it leaves behind. And the clues are seriously compelling. First, just look at how galaxies spin. The stars way out on the edges are moving so fast, they should be flung right off into deep space. But they aren't. Some unseen gravity, our dark matter, has to be holding them in place. Second, we see light from distant galaxies actually bending as it passes by huge clusters of other galaxies. We call this gravitational lensing, and it tells us there's way more mass there than we can see. And finally, the clincher. Our best computer models of how the universe formed, they just don't work without it. Dark matter really is the invisible skeleton for the entire cosmos. But holding things together, that's only half the story. Now we've got to move on to our second and honestly even stranger suspect. It's a mysterious force that's doing the exact opposite. Let's call it the runaway force. And this is dark energy. So while gravity and dark matter are working to pull the universe together, dark energy is this weird, repulsive force that's pushing everything apart. It seems to be a property of space itself, and it's causing the expansion of the universe not just to happen, but to speed up. You know, the biggest clue for this dropped back in the late 1990s. Astronomers were looking at these really distant, exploding stars, supernovae, and they noticed they were fainter than they should be. The only way that makes sense is if they were farther away than our models predicted. And the only explanation for that was that the expansion of the entire universe has been speeding up for the last few billion years, all thanks to this mysterious dark energy. Okay, let's pause for a second and do a quick tail of the tape just to keep our two suspects straight. You've got dark matter, which pulls things together with gravity and clumps up around galaxies. Then you have dark energy, which pushes things apart and is spread evenly all through space. One makes up about 27% of the universe, the other a whopping 68%. They're like two sides of the same mysterious cosmic coin. So for decades, the story seemed pretty consistent, right? Dark matter clumps, dark energy pushes, and the universe just keeps expanding forever. But what if there's a plot twist? I mean, a major plot twist. The very latest data is forcing scientists to ask some really dramatic new questions. And here it is. This is the shocking question that astronomers are seriously grappling with right now. What if dark energy isn't a constant? What if it's getting weaker? What if it's running out of steam? For a long, long time, the standard model of cosmology just assumed that dark energy was what they call a cosmological constant, basically an unchanging property of space. But new evidence from massive surveys like the Dark Energy Spectroscopic Instrument, or DAISY, is hinting that this might not be true at all. The data suggests dark energy might actually be evolving, and it could even have been stronger in the past than it is today. Now, I gotta say, this is still highly speculative, but the implications are just staggering. If dark energy really is weakening over time, that means one day gravity could become the dominant force in the universe once again. And if that happens, the universe's expansion could slow down, stop, and then reverse, collapsing back in on itself in a fiery big crunch. So, where does that leave our cosmic investigation? Well, right now, the case is wide open. The clues are pointing in brand new, completely unexpected directions, and they're challenging decades of cosmological thinking. But the good news is, we have a whole new generation of detectives on the case. We're talking about instruments like DESI, which is mapping millions of galaxies as we speak, the Euclid Space Telescope, and the Vera Rubin Observatory, which is about to come online. These are all designed to hunt for more clues and hopefully finally crack this cosmic mystery. These new investigators are going to give us the most precise measurements of our universe ever made. So the ultimate question really is, what are they going to find? Will they confirm that we're all just heading for a cold, empty future of endless expansion? Or will they find the first real evidence that our universe is actually destined for a dramatic, fiery collapse? The case, for now, continues.